Did you know it takes a lot more than you think to build an MRI room? The reason being is because you have to have what's called RF shielding. RF shielding is there to provide what's called a clean room for your MRI machine. Now you are probably thinking, oh, you probably use your typical drywall and your 2x4s to build this room. Well, hopefully by the end of this speech, you'll understand why it's needed, what goes into it, and how it's built. First, let's start off with why it's needed. So RF shielding is needed to create what's called a clean image for your MRI machine. The reason being is that the MRI machine is going to produce good frequencies and bad frequencies. And if a lot of bad frequencies get into the room, then this could cause what's called a blurred image, and the doctor will not be able to use the scan that is needed to determine what is wrong with the patient. Bad frequencies can be caused by a lot of things, what's called RF leaks, or if there's a liquid or some sort that gets onto the RF shielding and cause corrosion, then this is what's going to deteriorate the shield and allow those bad frequencies in to mess up the image. RF shielding is also needed to keep the 5 Gauss line of your MRI machine inside the room. So your MRI machine is going to have it's basically a big magnet. And the 5 Gauss line is something that it's a bad frequency that if it gets outside or if it reaches a person, it can mess up more than just your phone. If a person has a pacemaker in their heart, this can mess up a pacemaker and cause further issues. So what happens is once you have to provide what's called silicone steel if the 5 Gauss line goes outside the room. Now, silicone steel is not your regular steel. It's a steel that is approved to go inside of an MRI room. And it allows for that 5 Gauss line to hit that and hit the steel, and then what will happen is the 5 Gauss line will redirect into the room. Now, we understand why it's needed. Let's go into the planning stage. So the first things first, you have to determine what type of magnet is going to be inside of this room. The reason being is this magnet is going to have certain requirements that are needed in order for it to work properly. The reason I'm calling that a magnet is because that's what the MRI machine is. It's one big magnet. This branding of magnet will also inform you if there are certain extra items that need to be added on, such as a additional waveguide or certain filters that are needed in order for the magnet to shut off in case of emergency or things of that nature. You will also need to understand what kind of lighting or if there's any medical gas and where the mechanical ductwork is going to run into this room. The reason being is there are waveguides that everything that comes into the MRI room has to pass through. The reason being, these waveguides, like I said before, are going to let the good frequencies in and keep the bad ones out. With your mechanical ductwork, that waveguide is basically connecting to what's called a honeycomb. It looks exactly like a honeycomb, but it's made out of non-ferrous material. So what will happen is you'll run your aluminum ductwork on the outside of the room. However, once you get into the MRI room, you have to use what's called non-ferrous or non-metal materials because you're dealing with one big magnet. When dealing with your medical guys, you have to determine a specific size that's going to run into the room just because you have to provide a waveguide for that as well. When dealing with lighting, you're not doing your typical cam lights either. These have to be MRI approved lighting. With each MRI approved lighting brand, there comes a certain number of filters that are needed per circuit or a certain number of filters that are provided with the lighting that you purchase. So yes, an MRI room uses your typical light switch like you would use in any other room. However, the filtering is different because they are single line filters. Once you've determined this, you will now move on to your next step and create shop drawings. With the shop drawings, you are going to basically send these out to the general contractor or whoever you're working with, and they're going to approve or mark up your drawings in order to say, yes, this design for the MRI room works or it doesn't. In this instance, let's say it works. You will now move on to what's called your design phase. In your design phase, you're going to create a construction drawing set that you're going to provide to your GC or customer or whoever you're dealing with so they know exactly how you're going to build this room. Now, when it comes to building a room, there's two materials that you can use. You can either use aluminum or you can use copper. In my experience, I've used copper just because I've seen that it works better than aluminum and it lasts longer as well. It also provides a cleaner room for your magnet. So, for the sake of time, we're going to deal with copper. So with copper RF shielding, it comes with a copper sheet that's wrapped around fire-weighted wood. The reason being is you can't put your regular 2x4s for RF shielding when it's dealing with these frequencies. So you'll wrap copper around these things and you'll build what's called a panel. Once you have all these panels built, you'll move on to shipping and you're ready to install. When installing these panels, you have what's called installation schedule drawings that are going to tell you where each panel goes, how it goes, where your waveguides are supposed to be located on the panel, and things of that nature. You'll also use what's called RF screws. RF screws are used in the room because, again, you try not to use metal inside of an MRI room because you're dealing with one big magnet. So you'll put this, I call it a puzzle. You'll put the puzzle together and then you'll begin your interior finishes. That consists of your finished floor, your drywall, your suspended ceiling. You'll put your lights in there and you'll start running your filter, you'll start filtering the lights in order to get power to them and things of that nature. Once that is completed, the magnet is then delivered into the room. You are to close up the room and do what's called an RF shielding test. This is used in order to say that the RF shielding is working to what is needed, it is doing its job, and that there should be no issues with this room. Now, as I come to a close, I hope I didn't bore you. I hope I was able to teach you why RF shielding is needed, how it's built, and what goes into the planning of it. I know that it's something that doesn't come up in a regular conversation, but I do believe this is a great conversation starter. I'm always here to help, and if you have any more questions, please don't hesitate to ask.